So we cooked up a formula for taking the derivative of a function, which is just a constant times another function. A constant being just a number, right? And the formula worked out really nicely. It took some details to go through, right? There was evidence behind it, but here's the deal. We took the time to go through that evidence, so we never have to go through it again. Now we've just got a rule that we can apply, and anytime you have a function which is a constant times something involving x, the constant is going to be unaffected by the derivative, and the only thing affected by the derivative is the part involving x, which works out in some sense really nicely. So when you take a look at the function, if y is minus 2 times square root x, we want to find y prime. Well, when you have a function which is a constant, just a number, times something involving x, you know how the derivative comes out. The derivative is going to be that constant times whatever the derivative of the part involving x is. So in this case, we have minus 2 times square root x. The derivative is going to be minus 2 times whatever the derivative of square root x is. Well, the derivative of square root x is 1 over 2 square root x. So we've got minus 2 times 1 over 2 square root x is the derivative. And here actually this simplifies very nicely, because if you think of minus 2 as minus 2 over 1, you have a 2 upstairs, you've got a 2 downstairs, and this will simplify to just be minus 1 over square root x. But the long story short is, when you take the derivative of this function, minus 2 times square root x, since the first bit is just a number, we can use this formula to more simply go through the process of taking the derivative, because we know that that constant is unaffected by the derivative, and the only thing affected is the part involving x. Okay, what about this guy below? We've got p of x equals 7 over x. Now on the surface, this may look like it's a quotient because you've got something divided by something else. But knowing that we have a formula that we've computed for the derivative of 1 over x, well, let's sort of apply that to this situation. Because if you think of 7 over x as 7 times 1 over x, now you've got a constant times a function. And anytime you've got a constant times a function and you want to find the derivative, you can always take the derivative by the formula that we computed, leave the constant alone, and then take the derivative of what's left. Well, what's the derivative of the 1 over x? The derivative of the 1 over x is minus 1 over x squared. So long story short, when you simplify that out, the 7 is upstairs, you've got a negative and the x squared below, so that's minus 7 over x squared. And that's it.